My name is Thomas Diem, and I'll be talking about how to do derivatives and rates of change. This section encompasses how to find tangent lines at a given point by using a limit formula. It also includes how to find slopes between 2 points in word problems. This should be reviewed from earlier math classes. Let's start with how to find tangent lines. Suppose that you want to find the tangent line at a point a, f of a in the function f of x. You can find the slope of the tangent line by using the expression limit as h approaches 0 of f of a plus h minus f of a all over h, where a is the x value in the function f of x that the tangent line goes through. The goal is to simplify the expression and eventually get a value, which is the slope of the tangent line. We can then use point slope form to find the equation of the line. Let's do an example. We have the function f of x equals x squared, and the goal is to find the tangent line that goes through the point 2, 4. We know that a is the x value at the point of tangency, so a is 2. We can substitute all a's in the expression for 2. Then we get this. The equation of the function is x squared, so we can plug in the value of 2 plus h into that equation and 2 into that equation. And then we can simplify this expression more. And now that all the 4's canceled out, we can get rid of the h in the denominator. And now we're finally ready to substitute 0 in for h. The expression simplifies to 4. Now that we know the slope of the tangent line is 4, we can use point slope form to find the equation. Point slope form is y minus y1 equals m times x minus x1, where x1 and y1 are coordinates of the point on the line. We have the point 2, 4, and we know that the slope is 4, so we can plug in this information into the equation. If you want, you can then simplify this to slope-intercept form. The equation of the tangent line is y equals 4x minus 4. In some problems, it is necessary to do more steps in order to force the denominator to simplify. In this next example, f of x equals 4 divided by x, and we want to find a tangent line that goes through the point 4, 1. You'll see that this problem is slightly harder to solve. We'll start by setting up the expression to find the slope of the tangent line. Since we want to find the line that goes through the point 4, 1, our a value is 4. We can substitute that for a and get this expression. Now we can reduce 4 over 4 to 1. You'll notice that if we plug in 0 now, the expression will simplify to 0 over 0. So we need to make more simplifications. We can do this by multiplying the top and bottom by the quantity of 4 plus h, and this will eliminate the fraction within the fraction. We can simplify some more. Now the h on the top reduces with the h on the bottom. And finally we can substitute 0 for h, and we get a slope of negative 1 over 4. Now that we know the slope is negative 1 over 4 and the point is 4, 1, we can use point slope form to find the equation of the line. We simplify and get the equation y equals negative 1 over 4x plus 2. That's it. This section, derivatives and rates of change, also includes word problems and change in an interval of time. For example, the position of a particle moving in a straight line is given by the function f of t equals t squared minus 8t plus 18, where f of t is measured in meters and t in seconds. The problem asks us to find the average velocity in the interval 3 to 4. To find the average velocity between 2 points, we use the equation f of a minus f of b over a minus b. In this problem, our a and b values are 3 of 4. It doesn't matter which value is which because it will simplify to the same answer. We can plug in these values to the expression. Now we we can simplify, and we get a final answer of -1 meters per second. The problem also asks us to find the instantaneous velocity at 4 seconds. We can do this by finding the tangent line at x equals 4. We set up our equation. We can now solve this expression using the technique that we used in the first two examples. First, we substitute a for 4. And after that, we do a lot of simplification. And now everything cancels except for h squared. This expression reduces to the limit of as h approaches 0 of h, which is equal to 0. So the final answer is that the instantaneous velocity at 4 seconds is 0 meters per second.